Now, there are certain important units used in mechanics. In mechanics, there are certain physical quantities, and those physical quantities are represented in terms of dimensional equations. Dimensional equations are generally given in terms of mass, length, time, etc. So, like distance, displacement, length, depth, height, thickness, and the wavelength, all of them are represented in terms of distance. So we use m naught, lt naught. Then comes mass, inertia, inertial mass, and gravitational mass. However, mass is the quantity of matter contained by the body. So when we use the term gravitational mass, it means affected by gravity. Inertial mass, that is the property of mass itself. All these quantities have the dimensional equations of mass. So when we write L to the power 0 and T to the power 0, it means that any number to the power 0 will be 1. So dimensional equation of mass, inertia, inertial mass, gravitational mass will remain m. The speed, velocity, velocity of sound, velocity of light, all of them are expressed in centimeter per second or meter per second. So the mass is not taken into account here. So dimensional equation is given in terms of Lt minus 1 or m naught Lt minus 1. Then comes acceleration and acceleration due to gravity. Acceleration means rate of change of velocity. So we put the dimensions of velocity and divide by the dimensions of time. And we come to the conclusion that is the dimensional equation of acceleration and acceleration due to gravity will be m naught L1 t minus 2. Then comes angular velocity. Well, angular velocity is given by omega. The symbol for angular velocity is omega, and omega can be written as v over r. For v, the dimension is Lt minus 1 divided by r, that is radius, because angular velocity means body is moving in circular motion. So we put the dimensional equation of linear velocity and divided by time. So we find that angular velocity will be v over r. So v is taken as Lt minus 1 divided by L. So L will cancel off and the equation will become t to the power minus 1. So dimensional equation of angular velocity, the velocity gradient, the decay constant, and the linear frequency, that is all the same, and the dimensional equation will be m naught L naught t minus 1. Now comes the wave number. Wave number is 1 over lambda. The reciprocal of wavelength is called the wave number. And similarly, Rydberg constant, both the quantities have the same dimensional equation. In order to find the Rydberg constant, we must know the equation of wave number. So 1 over lambda is equal to, we write nu and then we put bar on that, and that is equal to the Rydberg constant into 1 over n1 square minus 1 over n2 square, where n1 and n2 are the number of orbits of the atom. So wave number is 1 over lambda. Lambda is in meters, so we have the dimension in terms of m naught, L minus 1 t naught. Now comes the gravitational constant. This dimension can be estimated from the formula of gravitation. The formula of gravitation is F is equal to G m1 m2 divided by r square. When we speak G capital, it will be gravitational constant, and m1 m2 are the masses, and r is supposed to be the distance among the two bodies. From this, we will make the subject of equation the gravitational constant, and we put the dimensions. And our conclusion will be m to the power minus 1, L to the power 3, and t to the power minus 2. Then comes force, weight, tension, centripetal force. Well, force is an agent which changes or tends to change the state of rest or the state of motion of the body. And weight is also the force due to which bodies are attracted towards the center of Earth. Tension means T. T stands for mg. M is mass and G is acceleration due to gravity. Centripetal force, that is the force responsible for giving rise to, or it is the force existing in circular motion. Centripetal means directed towards the center. All these physical quantities has the dimension of force. That is, force is calculated by second law of motion, that is, force is mass into acceleration. We put the dimension of acceleration as Lt minus 2, and the net dimension of force will become m to the power 1, L to the power 1, T to the power minus 2. Then we come towards work, energy, torque, movement of couple, and heat. Well, heat is also a form of energy. So whatsoever is the unit of work or energy, same is the unit for heat. Well, torque is calculated by formula force into perpendicular distance. So we put the dimensions of force, then we multiply it with the dimensions of length. And if we write movement of couple will be force into perpendicular distance. So we put the dimensions of force and displacement, and the dimension comes to be m L2t minus 2. Next is about linear momentum. Linear means in the straight line. Linear momentum is given by function m into v, that is m multiplied by v. So momentum, this can be represented by alphabet p, and it is equal to mass into velocity. So we put the dimensions of mass, we put the dimensions of velocity, and the dimension comes to be mlt minus 1. For impulse, the formula will be force into time. So impulse is a short duration force. So we put the dimensions of force and time, and the net dimension is again the same, that is m1 L1 t minus 1. Next dimension is surface tension. Surface tension is defined as force operating per unit length. So we put the dimension of force in the numerator and divide it by length, L. So it will become m1 L0 t minus 2. Next is about pressure, coefficient of elasticity, the Young's modulus, the bulk modulus, and the stress. Well, pressure is calculated by formula force over area, and same is for stress. It is also force per unit area. So we put the dimensions of force, then we put the dimensions of area, surface area, and then we make the calculations. It will become m1 L minus 1 t minus 2. Then is the Planck's constant and angular momentum. Well, for angular momentum, the symbolic representation is L, and it is calculated by function mvr. We put the dimensions of m, then v, then r. Well, we write m as it is, v will be Lt minus 1, and r will be in terms of length. And similarly, Planck's constant, its unit is joule second or erg second. So we put the dimension of joule, that is work, multiplied by time, and the net dimension comes to be m to the power 1, L to the power 2, t to the power minus 1. Next is coefficient of viscosity. Viscosity means the friction between the molecules of liquid and the surface on which those molecules exist. So the coefficient of viscosity is given by m to the power 1, L to the power minus 1, t to the power minus 1. Then comes the least count. Least count means that is the smallest length between the 2 points. So the minimum measurement that can be actually taken by an instrument is called the least count. Well, in case of the least count of a meter scale, which is graduated in millimeter, the mark will be 1 mm. Similarly, least count of a watch having second hand. We find that in a watch, there will be hours hand, there will be minutes hand, and there will be seconds hand. Between the two graduations of seconds, the difference is 1 second. So least count of a watch will have, that is, least count of 1 second. Then comes the least count of a vernier caliper. Well, you will remember that vernier caliper, the spherometer, the screw gauge. All of these, uh, all of these instruments are used for recording very, very small distance or length. So the least out of a vernier caliper means we take the main scale, we take the vernier scale, then one part of the main scale we consider and the value of the one part of the vernier scale, and then we take the difference of the two. Then comes the least count of a vernier caliper. For the vernier calipers, we find it is the ratio of the values of one part on main scale and the number of parts in the vernier scale.